Dronova.
My name is Irina Dronova. I'm a postdoc scientist at UC Berkeley right now, and the goal of my project is to measure how the potential of wetland vegetation in the delta to capture carbon and to provide habitat for birds has changed in the last 30 years, and what it means for ecological restoration, ecosystem management, and conservation in the region. So we know that plants, and wetland plants in particular, just by their natural ability to grow and to take carbon from the air, provide important ecological benefits. They reduce the amount of greenhouse gases in the atmosphere, they provide habitat for wetland organisms, and when they die, they become peat, which builds up over time and counteracts subsidence and rise of the sea levels. But measuring these services at the regional level is very difficult because we cannot go out in the field and measure every single plant. So I will use satellite images from NASA satellites to develop a method to measure and map vegetation properties that represent their capacity to capture carbon and provide habitat at the regional scale. And then I will apply this method to the 30-year Landsat archive data to look at how these properties have changed in the delta following changes in climate, hydrology, and land use. And the applications of the study will have three key directions. I will produce new data that will help to do carbon counting at the regional level. I will help to assess the suitability and vulnerability of bird habitats of the wetland-sensitive species in the region, and also will develop new cost-effective tools to evaluate the success of restoration projects in the area and monitor restored sites following the action, which is not a common practice in restoration at the moment. So this is in a nutshell what I will do. Thank you.
Thank you. Mr. McNichol.
Hi, my name is Gavin McNichol, and I'm a PhD candidate at the University of California, Berkeley. My thesis research, now supported by the Delta Science Program, focuses on getting a better understanding of methane emissions from restored delta wetlands. The wetlands that I refer to are located in the western central delta. This area has experienced some of the most extreme rates of land subsidence, and not only does that expose this landscape to the threat of catastrophic inundation, but it also has led to the release of very great quantities of carbon dioxide, which is an important greenhouse gas. And so it has been proposed to remedy these two problems. The potential of wetland restoration in these systems has been proposed. And so this would hopefully reduce the negative effects of the continued land subsidence, perhaps even reverse the trends. And it would also has the potential to convert these landscapes from net carbon dioxide sources into net carbon dioxide sinks, which of course may be of benefit to landowners or the state under future carbon trading schemes. However, one of the issues associated with wetland restoration is that wetlands are also the largest natural source of methane. Methane is another carbon-containing greenhouse gas, but it's 25 times more potent at trapping heat in the atmosphere than is CO2. And so the focus of my thesis is to look at how, first of all, to quantify methane emissions in restored delta wetlands and to assess to what extent methane emissions may offset the potential of these systems to sequester carbon. And also, in particular, we hope to gather samples that will allow us to look at the carbon sources of the methane released from these ecosystems, which is a substantial knowledge gap in wetland methane science. And we hope that the results of this work will inform better wetland design and management if that course of action is pursued in the Delta.
Ms. Gatti.
Good afternoon, I'm Emma. I just started my postdoc at Stanford University in association with the USGS in Menlo Park.
You are the only non-biologist to appear before us today, or maybe ecology is thrown in there too. How did they let you in?
They didn't treat me so well.
Yes, excuse me.
It's okay. My job is to assess the risk of the collapse of the levees in case of an earthquake. What we want to produce in the end is an hazard map which will illustrate graphically which areas of the delta are actually in risk of levees collapse and which are not. To do this, we're going to put together a 3D model of the geology underneath the delta, so not the surface, And we are going to use this model to understand where the faults are and if they are active or not. Once we know where the faults are, we're going to try to investigate those sediments that can produce liquefaction, which is the same type of phenomenon that has been observed in New Orleans during Hurricane Katrina. And once we know where the seismicity is and where those sediments are, we will be able to link them with the levees on the surface. And this should give us a pretty fair and complete picture of the seismic hazard in the delta, and more important, the potential of levees failure during an earthquake.
Okay. Well, thank you very much.
Thanks to you.
Could I just ask, in your research, will you be talking with some of the local folks that actually, you have some good historical perspective? Obviously, USGS has their own database, but sometimes out in the field you can learn some very interesting things as well. So will you be doing that, Emma?
Yeah, we're actually using the database of data collected by several sources, like the Department of Water Resources. So we actually, the data that we are using are coming from so many Californian local sources, and I think this is why I was also here today, to hear the concerns of the locals and which problems are considered more important or not. So definitely it's in our
Some of it may
plans.
only be anecdotal. I know science has to have some more empirical types of databases. I will just say, though, that if you're able to get out in the field and visit with some folks who know and manage those levees, but also a lot of times have generational history about, even in some cases the material that was used, let alone that may be identified in the database. So I just would encourage you, if you have a chance to get out in the field and talk with folks beyond drawing from obviously those databases, some of that may be helpful and may lead you in places you wouldn't necessarily go just looking at the information that's available. So
Definitely, yes.
okay, good, thanks.
Thank you very much. Ms. Hastings,